Well, greetings everybody. So what you see here is a telescoping series problem from the homework assignment. And my ultimate goal is to say something about this partial sum formula, but I think I need to work up to that. And so the way I'll do that is I'll adapt this problem, but instead of the index of summation being k equals 0, let's start it at k is equal to 1. Okay? All right, so I'm going to make a point about how this series works if it starts at 1. So if I was going to analyze the telescoping series, I would use partial fraction decomposition to split this one fraction up into two fractions. Okay, and that's not the point of this video, so I'm not going to show that. And let's just say that we can take that, we can split it up into this. And seeing it this way is what allows us to see it's telescoping. Okay, so I'll write out some of the terms so you can see that it's telescoping. This series starts with k being 1. If k is 1, I get the first term, which is 1/12 minus 1/16. If k is 2, I get the second term, which is 1/16 minus 1/20. If k is 3, I get the third term, which is 1/20 minus 1/24. And it goes on from there. So it's telescoping. You can see that the middle collapses out of it. And that's what we would expect. Okay? Now, as an example, I'll say, well, all right, the sum of the first three terms, as I have given it, where this is the first term, the second term, and the third term, is 1/12 minus 1/24. And so if I was going to give you a formula for S subscript n, the partial sum, the sum of the first n terms, which is what I want to talk about for this question, then that would be 1/12 minus 1/2 over 2n plus 6. Okay, here's how I get that. Obviously, the partial sum term has to start with 1/12 because that's never going to cancel out of this. But I get this from that one. See how this 1/12 that leads it doesn't cancel, and then this 1/24 also doesn't cancel. Where did that 1/24 come from? It came from this 1/2 over 2k plus 6. So I'll adapt that. I'll get 1/2 to n plus 6. So this will work. The 1/12 gives me 1/12, and then this term, which will vary the more terms I write out, right? If I go to the next one, it's not going to be 1/24, but it will come from that. It'll come from this formula, 1/2 over 2k plus 6. That's how I get that. I can simplify this a little bit. I can put this 2 down there, and I'll get 4n plus 12. And if you want, you can check this. What would make this right, or what would corroborate this correct, is if I put a 3 for n, it would give me the sum of the first three terms, which you see here, and that's 1/12 minus 1/24. And if you put 3 for n, it in fact does that. Okay, put 3 for n right there, you get 1/12 minus 1/24. Okay, now this is just a preliminary example where the counting with this series starts at 1. Now in this one, the counting starts at 0. Okay, so I'm thinking, in principle, that wouldn't change anything about it. Like, I'll take my series, I'll split it up by partial fraction decomposition. That's not going to change even if the series starts with k is equal to 0. And then I'll write out the first three terms. I get the first term by letting k be 0 because that's when the counting starts in this series. Okay, I get the second term with k being 1. I get the third term with k being 2. Well, notice how these are off by 1. K being 0 gives me term 1. K being 1 gives me term 2. K being 2 gives me term 3. And that would continue. Now, I'm going to show you again by example what the first three terms looks like if you add them together. What's the third partial sum? What's S3? Well, look at it. The middle cancels out as it would for telescoping series. I get 1/8 minus 1/20. So when I give you Sn, the formula that tells me what the sum of the first n terms are, it must produce 1/8 minus 1/20 if n is 3. Okay, because there's term 1, term 2, term 3. This tells me the sum of the first n terms. If I let n be 3, it's got to give me that. It's got to give me 1/8 minus 1/20. Okay, so here's what would do that. Notice that I get 1/8, right? That's not going to cancel. And then this has to give me this, okay? This has to give me that 1 over 20, or whatever that term is there that doesn't cancel. But notice how in this problem I said, well, I will take this, it's going to give me that term, and it's going to be part of my partial sum. But here, I'm going to have to adapt it, okay? So there's a few ways I could look at that. Notice how I said that these were off by 1. K0 gives you term 1, K1 gives you term 2, and so on. Well, I can just take that formula, which does in fact give me this term, and then shift it down by 1. So imagine instead of that being a K, you just took that number and took away 1 from it. It would be 1/2 over 2 times K minus 1, then plus 6. All right, now here the variable is in, so I'm going to say 1/2 over 2 n minus 1 plus 6. So it's just that formula that's here shifted down by 1. Okay. Another way you can see it is whatever this formula is, okay, when I put a 3 into it, it's got to behave like putting 2 into it. All right, like so when I put 2 right there, this one's got to behave like that, but for me putting a 3 in. So think about it. If I were to put 2 for K, 1/2, 2 times 2 plus 6. All right, well, when I put in 3, this one's got to do that. So how's that going to happen? Well, if I took 3 and I subtracted 1, if I shifted it down by 1. Okay, so there you go. That's how we would have to do it. It's all because of this starting at 0. It's because this mismatch, those being off by 1. It's why I have to take that formula and just shift this variable down by 1. Okay. But you could always check it and make sure that it works. If you weren't sure which way am I supposed to shift, well, when I put 3 into this, okay, here's my final simplified form, it's going to have to give me what? 1 over 8 minus 1 over 20, okay? And it does, all right? If I put 3 in for the n, it gives me the number. It gives me 1 over 8 minus 1 over 20, and that is in fact what you should get if you combine the first 3 terms. So it works out. Now, that's all this is supposed to do, Sn, right? That's what I said here in this bubble. It just has to produce the sum of the first n terms. If you want to take 3 terms for an example, it's got to produce what you see right there when you put 3 in. And in the end, that's how we know that it's working correctly.